Today on Campeche's Corner, we're going to look at ways to prove that quadrilaterals are parallelograms. There are 5 ways to prove that a quadrilateral is a parallelogram. Number 1 is to show that both pairs of opposite sides are parallel. The second way is to show that both pairs of opposite sides are congruent. The third way is to show that one pair of opposite sides are both congruent and parallel. The fourth way is to show that both pairs of opposite angles are congruent. The last way we can show that a quadrilateral is a parallelogram is to show that the diagonals bisect each other. In our first set of problems, we're going to ask if the given quadrilateral has to be a parallelogram, and then we want to know why or why not. In looking at number 1, we have 3 measures of angles given. Now we know that the last measure of the angle has to be 110 because a quadrilateral has a sum of 360 degrees. So in the end, we can see that both pairs of opposite angles of this quadrilateral are congruent, so therefore it is a parallelogram. That's a yes. In number 2, if we look at the markings, we have one pair of parallel lines, that's given, and we can also see that that same pair of lines are congruent. So that is going to be a yes, it's a parallelogram because we have one pair of opposite sides, both parallel and congruent. That's a yes. And looking at number 3, we have several markings we have to pay attention to. So we see that we have one pair of opposite sides are congruent, and we have one diagonal is bisected by the other diagonal, but that's just not enough. We need both pairs of diagonals to bisect each other, or we need both pairs of opposite sides congruent. So we cannot conclude that this quadrilateral is definitely a parallelogram. In these next set of problems, it says what values for x and y will make the quadrilateral a parallelogram. So in looking at number 1, we're given some angle measurements. So I know that opposite angles of a parallelogram are congruent. So if I can have that work, if I can make these angles equal or congruent, then I can make this quadrilateral a parallelogram. So I have 42 is equal to 3y, divide both sides by 3, and y is equal to 14. Now, I know that parallelograms have parallel lines, so if I extend this, if I can say these lines are parallel, then this line right here would be my transversal. And if that's the case, then I know 8x minus 6 and 42 would be same side interior angle, and they would be supplementary. So if I set up my equation there, 8x minus 6 plus 42 is equal to 180. Combine my like terms, I have 8x plus 36 is equal to 180. Bring that 36 to the other side, and 8x is equal to 144, and x is equal to 18. So these values would make this a parallelogram because we would make opposite angles congruent, and at the same time, we would make sure that these same side interior angles are supplementary. In our next problem, this quadrilateral has diagonals, so if I can show that the diagonals are congruent, then I can say this quadrilateral is a parallelogram. So let's write our equation. So we have 3x minus 40 is equal to x, and then I also have y squared is equal to y plus 30. So in my first equation, if I solve for x, if I bring x to the other side, I have negative 40 is equal to negative 2x, so x is equal to 20. Now, in solving for y, I need to bring everything to one side of the equation because I have y squared to the second power, and I want to see if I can factor it. So the only way I can get y squared is y times y. I know that my signs are going to be opposite, so I have plus or minus. And I'm looking for factors of 30 that when I subtract, I get to 1, so that would be 6 and 5. So since my middle term is negative and my 6 is my higher value, that's where my 6 is going to go, attached to my negative. So I know if y plus 5 times the quantity of y minus 6 is equal to 0, I'm going to use that zero product property. Y plus 5 is equal to 0, or y minus 6 is equal to 0. So y either has to equal negative 5 or y is equal to 6. Now if this was just an algebra problem, that would be the correct answers, but it's not, it's geometry, so we need to take a look at what we have. So if we have y squared, we actually can have a negative number. Negative 5 squared is positive 25, so that would work. And if we plug it into this other part of the diagonal, we would get negative 5 plus 30, which is also 25. So that possibility is okay. If we do the same thing with 6, y squared is 36, and on the other side we have 6 plus 30, which is 36. So in this case, both values are okay. Sometimes the negative value doesn't work because we can't have a negative side or a negative length or a negative measure of an angle. But in this case, that negative value is okay because of how it's written in our diagram.